Welcome, everyone.
Hey, everybody. Welcome. Thank you all for coming into our session. Happy Friday the 13th. We will be presenting on reducing cognitive load, paving the golden path on your internal platform.
Yep, and well, happy to introduce myself. I did another presentation on Knative this week, but today I will be talking a little bit about platforms. My name is Mauricio Salatino. I'm a staff engineer at VMware, and my full-time job is maintaining a project that's called Knative. We just build that framework with different companies, but I'm also writing a book that's called Continuous Delivery for Kubernetes, where I'm just trying to bring a bunch of open source tools together so you can deliver more software on top of Kubernetes if that's your thing. I was going to ask about how many people here is using Kubernetes or looking into. That's a very good number, right? That's
good.
And yeah, so basically the book, it's a little bit about that, like about developers and the tools that you can use to just speed up your journey to Kubernetes. Feel free to check it out. I think that there is a discount code at the end of the presentation if you are into reading books still. Yeah, that's me, Paula.
Hi, so my name is Paula Kennedy. I'm the Chief Operating Officer of a company called Syntasso. We founded last year. We help customers to run their internal platforms as products. We also build an open source framework called Kratix that Mauricio is going to show us a little bit later on. The product itself is early days yet. It's open source, available on GitHub. So if you want to have a look at it and give us some feedback, we would love to hear thoughts, feedback, comments on what we're building and whether it's going to solve some challenges for you.
Yeah, and today, as Paula just mentioned in the title, in the presentation title, we will be talking about a little bit about theory behind defining golden paths for your teams so they can just basically get whatever they need in order to do their work. That's very related with platform building and internal platforms. So Paula is going to go over some theory around that that I think that we need for this space because it's pretty new. And then I will jump to show you some tools in actions. Again, some open source tools that you can use in order to start your platform building journey. If you're already building a platform, these tools are very heavily focused on Kubernetes. So basically allowing you to reuse a bunch of other tools that you might be using already. It also opens the door for that multi-cloud approach where you use Kubernetes as the main abstraction point. So Paula, you can get started with the theory side.
Thanks, Mauricio. Okay, so as Mauricio mentioned, because of the domain we both work in, we've chosen to give our demo today on Kubernetes and some related technologies. So I want to start just talking a little bit about that first of all. In the most recent Cloud Native Computing Foundation survey from February this year, they found that out of 2,000 respondents, 96% were either using or evaluating Kubernetes. And as Mauricio just asked, it seems like a lot of people in this room are also looking into Kubernetes or using it. There's probably a bit of selection bias from the CNCF survey, honestly, but there are reportedly more than 5.6 million developers using Kubernetes today, which is quite a lot. So you could say Kubernetes is becoming ubiquitous, but it's not really a silver bullet. Back in 2017, Kelsey Hightower said that Kubernetes is a platform for building platforms. It's not the end game. It was never intended to be an all-singing, all-dancing platform as a service. And since Kelsey said this nearly 5 years ago now, we've seen a huge explosion in the ecosystem of tools and related technologies all around Kubernetes. You might have seen this slide before. In fact, you might have seen it already at this conference. This is the CNCF landscape image. Don't worry if you can't read all the things. There's a lot of things on here. But really, the reason I'm putting this slide up is just to illustrate how many options there are. Not everything on here is specifically Kubernetes related, but a lot of these tools and frameworks are. We're going to, in the demo that Mauricio is going to do, he's going to pick just a couple of these tools and he's going to show you how to compose them together to build a platform. But if you just look at the number of options here, if you're responsible for building a platform or running some software, how do you choose which of these thousands of projects that you need to complete your task? There's just a huge amount of complexity. You've got to think about what's the right tool for the job, and then how do you use it, and then how do you bring it into your tech stack? There's just a huge amount of complexity, which leads to a very high amount of cognitive load. So I'm going to talk a little bit about that. So what is cognitive load? It's a theory that was first researched in the late 1980s by John Sweller. and there's lots of information you can find about it online. There's actually 3 different types of cognitive load. But a very basic definition by Frederick Reif states that cognitive load involved in a task is the amount of information processing required by a person to perform this task. Now, the problem with this, as stated by De Jong, is that when your working memory capacity is exceeded, it makes it very hard to actually complete the tasks that you're doing. And if the task that we're trying to do is write some software or deploy some software, then in a very complicated tech landscape that we're dealing with, it's important to try to reduce that cognitive load as much as possible so that we can focus on getting our software done and out into production. So this leads us on to the questions. What can we do about it? And who should be responsible for doing what? Now, Mauricio and I, we're really big fans of Team Topology's book. How many people here have read the book? Oh, good.
Good stuff.
Quite a lot of people. OK, so we love it. It's been written by Matthew Skelton and Manuel Pace. It was released in 2019. I'm not going to go into masses of detail because that would be a whole talk on its own. In fact, it's a whole book on its own. But it's loosely, it's about how to organize teams with clear boundaries so that you can have a fast flow of value across the business. And there's team organization and interaction modes. Now, this gives the summary of them. But for the purposes of this talk, we just want to focus on just a couple, like a subset of this. So a pattern that we see being really successful, and it was highlighted in the State of DevOps report from Puppet for the last couple of years, is where you have a central platform team supporting multiple stream-aligned teams, as Team Topologies define it, or application teams. They are the platform team is then providing their platform in an X as a service mode, so basically self-service, giving the developers a self-service platform that they can use when they need to. Now, you might be thinking that you can just buy this platform off the shelf and then give that to the developers and they can have at it, right? So you could go to a big cloud provider or big software vendor and just buy the platform and give it out to people. But that's not the complete answer. Another finding from the State of DevOps report was an internal platform, in nearly all cases, isn't something you can buy outright. It's something that is tailored to the needs of your organization. Your business has specific requirements that it needs. It has a specific value that you need to get from your platform. And even if you can go out and buy large parts of it, even if you can go out and buy a big platform, there are still going to be that kind of 20% of things that are unique to your business that you need to wire together. Team Topologies describes a platform as a curated experience for engineers, and the key word there is curated. The platform needs to make sure that it's offering everything that your product teams need, and that it's not increasing their cognitive load by using your internal platform. It should be reducing their cognitive load. So we need to make sure that the platform itself offers the right tooling, the right setup, the right credentials, everything that the developers need to get their jobs done. Which leads us nicely to the topic of golden paths. Now, Spotify defined golden paths as the opinionated and supported path to build something. So in other words, this means offering developers the best way to get to production. By building golden paths, we can do a few things. Firstly, we can kind of align on a set of tools in the business and reduce the number of choices that developers have to make. So if you think back to that CNCF landscape slide, there were so many choices. By kind of aligning on a tool set, it makes it easier to have developers have fewer choices to make. And by trying to streamline on a set of tools, it means teams using them can share best practices. So if someone's using Knative in one team, then another team can share their tips and tricks on how to use it. And it also means that when we have these golden paths, we can build in certain guardrails. So if your business has specific compliance, security, scanning, monitoring, certain things that are needed as part of the business requirements, they can be incorporated into the golden paths so that developers know if they deploy software on the internal platform, it's going to be supported, it's going to be secure, it's going to be approved by the business because they're following the approved route to get to production. Now, it's not to say that developers can't choose different tools, right? Golden paths are not trying to be set in stone, mandated paths. They are the best way. We tried to make it for developers the easy way as the best way, but developers could choose other things. That's fine, but the onus then should be on them. If you choose something that's outside of these golden paths, they should then be responsible for supporting it themselves. Now, the specific ways that you, in your organizations, are building golden paths will be unique to your business. What we want to show on this talk today is just an example of one way you could do it. So we're going to just pick a few tools from the open source, from the landscape, and just show you some ways of how to put a path together. We're going to take you through an example of a fictional company called EasyEat, which is quite hard to say. EasyEat, they are a food delivery app. They're a medium-sized company. They have a number of product teams or stream-aligned teams. And then following the team topologies model, they have a central platform team who are supporting these different product teams. They're using Kubernetes as their platform. And the platform team understands the importance of reducing cognitive load for their developers. In fact, they're incentivized to try to make that happen. And they know that they need to be able to make it as easy as possible for those product teams to get their features into customers, because they've got to go as fast. This is their business model. They need to get features out to customers as fast as they possibly can. Now, in our example, one of these teams has got a new product idea. They want to develop a set of features around spicy foods. This talk's going to make you hungry, I think. Some spicy foods. And they've been researching this idea for a while. They've got an idea what they need from their development environment. They're now ready to collaborate with the platform team. So the collaboration goes something like this. The product team developers, they've got the idea of what they want, and they're going to talk it through with the platform team. Now, that might look like a series of workshops and kind of interviews. It could be a set of practices for collaboration. What the product team doesn't want to worry about is how things are wired together. They don't want to worry about all the different pieces and like requesting an environment and then having to do a thing and then pull everything together. They just want to be able to make a request for this dev environment, know that it's going to have everything that they need, the tooling, the environment, the credentials, everything that they want, and they want to be able to request it when they want it. They don't want to have to raise a ticket and then wait for some time and then find it hasn't got everything they need. They want to be able to request it and get it. And then through this collaboration, the platform team have understood the requirements. So they've had lots of collaboration. They understand what the product team needs. And so what the platform team now wants to do is to pave this golden path for the development team. They want to meet the needs and make sure it's available. And they want to make sure that it's available on demand. So that once they've done this kind of work, they themselves, the platform team, aren't going to be facing this mountain of tickets coming in, requesting it. Once it's kind of configured, then the product team can just request when they want it. So platform team is going to build this golden path. They're going to provide everything that the app team needs. Mauricio is going to show us this. We're going to have some hat wearing. So to start with, Mauricio is going to wear his platform engineer hat.
Let's do that. So as a platform engineering team, basically, that's going to be a team. Paula is mentioning a platform. So let's talk a little bit more about like what are the expectations for this platform in general, right? If you are talking about Kubernetes, that might mean a Kubernetes cluster, yes, but at least from my personal experience, what I believe that this platform will be doing is that a bunch of things, a bunch of completely different things, and that's basically what our golden paths are. And these golden paths will include this kind of stuff, like going and creating cloud resources, maybe in different cloud providers, maybe in the cloud provider that you're using right now. It's going to also need to deal with creating repositories for storing kind of like the team's source code and having all the pipelines required to transform that source code into something that you can run. But more importantly, it will need to cover a certain set of things like compliance, security, like Paula mentioned, right? Like making sure that whatever we are using or whatever we are requesting is fitting into our costs, and we have the right billing mechanisms just to create these resources, to provision these repositories, to configure these pipelines and all that stuff. So as a platform, we can go just a little bit deeper, but as a platform engineer, we will just be building something that allows our product teams, our developers, just to go and request these resources in a way that they don't actually need to know where these resources are being created, or where the credentials are to access these resources and all that stuff in a way that it doesn't require creating a Jira ticket and waiting for 3 weeks, right? Like whenever they need an environment, whenever they need something from the platform, they can just go and request it by themselves. So let's go a little bit deeper on that idea. When I think about creating cloud resources and when I'm talking about Kubernetes, for the sake of simplicity, and in this presentation, I will be referring at something that is called the platform cluster. Right? Like you can have multiple platform clusters, but for this presentation, I've created a cluster, a Kubernetes cluster inside Google Cloud. And when I think about provisioning resources, I do think about a project that is called Crossplane. How many of you folks knows like Crossplane or have used it before? Okay, a bunch of folks. Crossplane basically allows you to create cloud resources, let's say databases, Kubernetes clusters, messaging, buckets, and stuff like that you usually create in a cloud provider by using, Kubernetes resources. So if you have a platform cluster that it's a Kubernetes cluster that you can send requests to it, you can now with Crossplane, if you have Crossplane installed and you have one of the Crossplane providers for example, Google Cloud or Amazon, you can send Kubernetes resources to that cluster saying, I want a new Kubernetes cluster to be created in that specific cloud provider. And Crossplane is going to take that resource, go and create a cluster, and basically connect these two things together. So now you can start managing infrastructure using Kubernetes APIs. That basically means that you can also start implementing GitOps, right, like with this, where you just store all the configurations of what your environments are in a Git repository, and then you just sync that using Crossplane, and then Crossplane will take care of creating these resources and maintaining those for you. It's a very interesting project. It does provide a lot of other things, like, for example, composition. So what you can see here in this, in this orange box is basically some kind of like a composition template for my projects, right? Like if I've already collaborated with my product teams and I can like identify what kind of things do they need. They need a database, a cluster, and some other stuff. I can package all these definitions into a Crossplane composition, and then I can just start new instances of these templates, right? So I don't actually need to go and create all the resources manually for each of these things because I know that these projects will require these things. And the good thing about compositions is that they provide a way for like configuring them together, right? So when you create a cluster, you want to make sure that that cluster has access to the database, and the users that are trying to connect their applications to this database have the right credentials and all that stuff. So it's pretty powerful. You can create higher and higher level abstractions of how to instantiate and provision new infrastructure. At the same time, as a Crossplane user, at the end of the day, you will have another Kubernetes resource with all the credentials to access these resources that were created. And that's pretty useful. If we take a look at Crossplane a little bit more in detail, let me show you some YAML, as you would expect in one of these presentations. And that's why I'm wearing this hat, right? Let's mirror this. Oh, it's not mirroring. Here, mirror. There you go. As a platform engineer, I will be dealing with YAML. So let's do that for a bit. So what do I have? In Crossplane, again, as I mentioned before, you have compositions, and you define compositions using a kind of like a Kubernetes resource. And for this composition, as I mentioned before, I have this spicy project, where I'm going to be dealing with the spicy food projects. So I created a template for GCP. In this case, what I'm defining here is what do I want to create in Google Cloud whenever I create a new instance of this resource in Kubernetes. And for GCP in particular, what I'm creating is a network in Google Cloud. I'm creating a Kubernetes cluster, and I am creating a node pool, which is like the array of machines that my Kubernetes cluster will use. As you can see here, I can be very opinionated here, and this is where the platform team needs to work on the requirements that they have, right? In this case, I am creating clusters and machines in the US, right? And by doing that, I can abstract my product teams to even think about where these things are running. Like they actually don't need to know where this is running, and they don't even need to know what kind of machines they have, right? As soon as the platform team understand the requirements from that product team, they can decide what kind of machines, how much memory, how many CPUs they need, what kind of access they need to other resources and all that stuff. So basically, you just put all the things that you want to bundle into these templates, into this resource. And what you can do with Crossplane is you can create a package with this definition, right? Like you create another file which basically has a name and define kind of like the kind of resource that you are trying to create. And then you can start from that point using that resource to provision all the things that are defined in the composition. So the only thing that I wanted to show you is that I have a Kubernetes cluster that it's called platform. Again, I've created this cluster and installed Crossplane in this cluster. And what I'm going to be showing now is how can I create one instance of this template, right? Like pretty simple, nothing fancy. But I can show you applying, basically creating one of these new project templates. I think this is the YAML file that I want to show. As you can see here, there is no. It's a very simple YAML file, 4 lines, 5 lines. And I've decided to expose this property here, which is the Kubernetes cluster version that I want to use for this environment. But that's not a very good example here, right? Like what I should have here, it's more like the size of the project, the security level that I need as a product team for this thing, right? Like if I need a dev environment, probably I don't actually need a lot of things in there. But if I am aiming for a QA or like a performance testing environment, I can probably specify here with some kind of property that will basically change how the composition is created. So if I apply this here into my cluster, right, like I'm just doing kubectl apply, and that's a spicy project template GCP YAML file. Again, I'm sending this Kubernetes resource to my Crossplane installation that I have in Google Cloud. And because I've configured that Crossplane installation to have access to my Google Cloud resources, what Crossplane is going to do is going to go ahead and create the resources for that composition. So if I go back to Google Cloud here, like the consoles and the list of the clusters, I can see that a new cluster is being created there. It's being provisioned. And what Crossplane is doing is basically keeping track of the state of those resources that are being created, right? Remember that I decided to create a node pool, a network, and a GKE cluster. The only thing that I'm showing you here is like the cluster itself, but the network is created, and also the node pool for that cluster is created. So what I can do now is I can just use this new type that is called spicy for short to list all my instances of these templates, right? And in this case, I have this one that I've just triggered. And it's still in false because it's been provisioned, right? As soon as this is finished, I will just get this to ready, and I will also get the credentials to access that cluster that was just provisioned. And the cool thing about this is that I can, for example, I can delete this instance, right? Like the one that I've just created, and Crossplane will take care of cleaning up all the resources in Google Cloud. So there is a one-to-one relationship between the resources and the things that are being provisioned. So I just deleted the resource from my Kubernetes cluster. Crossplane will reconcile that, and at some point, this cluster is going to be deleted. Right? Like, you should take 30 seconds maybe. But believe me, that's going to happen at some point, right? This is going to disappear. It's not going to stay there. So again, Crossplane is acting as kind of like this abstraction layer on how do we create infrastructure. That is pretty cool in my opinion. It's very Kubernetes native, and it feels natural to me as a Kubernetes user because I can go then, again, as I mentioned before, and put that YAML file into a Git repository and then do GitOps with that.
That's still quite low level, right?
The problem with this is that we are just talking about provisioning infrastructure, right? And that might not be kind of like what the golden path is, right? Like we have defined now what infrastructure our teams need, but there are some other aspects of this that needs to be covered by our golden paths, right? Like now we know that we need to create some resources. We know that with Crossplane, we can do this in multi-cloud providers, doing it in the same way, using Kubernetes resources. But this is pretty still low level. As Paula mentioned, this is like just infrastructure. Our teams need more stuff on top of it. And that stuff usually might be related with CI/CD, right? Like how do we build software, how we deploy things into these cloud resources that we just provisioned. I'm not going to show any Tekton or build packs example here, maybe a little bit of build packs at the end. But in general, what I would think that this platform will be doing is managing Git repositories, for example, the security, the access to these Git repositories, and then managing all the way from source to having packages that I can run and deploy into these instances and into these environments. But in general, like as a developer, again, I don't want to go and learn how Tekton works, how do I install Tekton in my Kubernetes clusters, how do I configure Tekton pipelines, or even how do I build my Docker images, right? Like how do I build my containers? If I'm charged as a developer to learn that, the cognitive load is quite high. I need to be up to date with all the CVEs and all the security issues by choosing different base images and all that stuff. That's something that if the platform can take away from me, I will be super happy, right? But as a platform engineer, I can use tools like Tekton and Buildpack in combination with Crossplane, as we saw, to have the right building blocks to provide development teams all the things that they need configured out of the box. So if I were me and I'm building this platform cluster, I will definitely install Tekton in there, and I will definitely have my own curated set of build packs for building the projects that my teams are going to use. Again, having some kind of templates and stuff like that. Yep. Which takes us to the next step, right? When you start looking into the CNCM landscape, it's a pretty wild space, and things are changing really, really fast. And when you end up struggling with is how do you glue all these things together? All these things are using Kubernetes as the main base kind of like project, but they are not well integrated. And it will take you some time to figure out how to integrate tools together. And that's, I guess, is like the full-time job of platform engineers, just to understand these tools, how they are going to be used in order to create our golden paths. And that's where Kratix comes into the picture. Like Kratix is the project that Paula's teams is building. And what they are focused on is into providing this concise API at the right level of abstraction for development teams to use to request things. But those things are going to be very specific to your company or to your domain. That's why the curation on the amount of tools that you're going to use is part of what the platform team should be doing. Kratix gives you that powerful way of creating a Kratix promise, which basically encodes this golden path. It basically says, this is what I want to expose to my development teams. So this is what they can request. And behind the covers, I will just coordinate and glue all these tools. So they provision and install the things that our teams will need. So they don't need to actually care about I need to go to that cluster and then install this tool and then just give the permissions and then just making sure that my developers can use that cluster. So just to recap there, Kratix here is giving you that concise API for development teams to use. And it will make a lot of sense, for example, to have a platform portal. Again, that can be something that your company already have, where they can go as users and request stuff to the platform. And the platform will basically provision things, configure things, and then give them access to these environments. So as a platform engineer, I would definitely will be focused on that curation of tools and making sure that I create the right APIs so my teams can request the stuff. From this point of view, I think that I will just be,
switch.
Yeah, I think that I will be switching hats because now,
you're going to do
right?
the
So
promise?
as soon as I have a platform,
You're going to show doing your promise.
yes, I need to show that. That's true. But I will show that. Oh, that's true. Okay. So from a platform engineering point of view, give me a second. I will show you a bit of more YAML, which is basically how do you encode that with Kratix, right?
Yeah.
That's a good point. That's a very good point. Thank you very much for the reminder. So what you can do with Kratix is a project, as Paula mentioned. It's there. It's open source, and it's giving you a bunch of tools so you can encode these golden paths, right? Take a look at the GitHub here. It's pretty cool. They have some very good getting started guides, but it's a project that you will only reach if you are building platforms, right? Because it does make sense for this kind of context. So what I have here is, and what I wanted to show you is the promise itself. So again, in the platform cluster that I have in Google Cloud, I've installed Kratix, right? So I have Crossplane installed. That's the thing that I showed before. And I've already installed Kratix in there, and I can list the namespaces here. So you know that I'm not lying. So I have Kratix there. It's installed. It's running. And as soon as I have Kratix installed in there, what I can start doing is I can start defining these promises, which basically are the APIs definitions that my application development teams will use. And in order to define a promise, what you do is you create, again, another resource, which is a little bit more extensive, but it has some key points in here. The first thing is defining what our development teams are going to be requesting. Right, like before, when we talk about Crossplane, we define the cloud resources that we wanted to provision. In this case, we go one level up in the abstraction chain. And in this case, what we want is development environments, right? We want development environments for these teams so they can create their own development environments whenever they want. And for that, you define a type in Kubernetes. Like in this case, you define kind of like a Kubernetes resource. This is a custom resource definition, the way that you extend Kubernetes. And then you define kind of like an API with a bunch of properties that you want to expose to your teams. Again, if you want a development environment, how maybe kind of like the size of the environment that you are requesting, for how long maybe you want to use it for a week and then just shut it down. You will just create the APIs for defining these parameters. And what you can see here down in the bottom, I don't know if you can see it there, but basically this is like a pointer to some kind of a pipeline that will be in charge of gluing all these tools together, right? Like as we saw before, we'll be using Crossplane to create resources. Then we want to install, for example, some tools in the cluster that we are creating, and configure some roles maybe, and just doing more setup stuff that we don't want our developers to do. So as soon as I create this kind of like resource, I apply this into my Kubernetes cluster where Kratix is installed. And basically now I'm allowing people just to request new instances of these resources will basically execute the pipeline. And again, this pipeline, like the pipeline definition itself, you define that in a way that Kratix has defined. But the idea there is that you can use any tool to coordinate and glue all the tools that you are picking for your teams to use, right? So you can imagine that as a pipeline that will install things, will create cloud resources, will configure all the things, and at the end of the chain, basically, your developers will have, your like the credentials that they need in order to access the new environment. Which takes me to the next hat now. I think that now I am entitled to use the next hat, which is about like the developer perspective, right? Like from a development team point of view, again, I just want to go to a platform. I can just put the slideshow again, I think. Yes. So as a developer, I can just go to my platform. In this case, let's say Backstage or any kind of like user interface. What I want to say is I want a new spicy dev environment for me just to start working. And I actually don't want to interact with the platform team. I just want to interact with the platform, right? So I go with the platform, just create that request. It will create a new instance of this resource that I just showed you, this promise. And Kratix is going to be in charge of basically coordinating and just running that kind of like supply chain in the back end just to create a new spicy dev environment. For this particular example, what we have configured Kratix to do is to use Crossplane to create the cloud resources, and then as soon as the cluster is ready, we want to go there and install Knative, which is the project that I'm building as well. But it does make sense in this case, and it's something that we noticed like over the years, like while working with Knative, like as a developer, I'm kind of like tired of just going and installing Knative on my own when I get a cluster, right? Like that's something very painful in my opinion. It was said yesterday, I do believe that Knative should be installed in every Kubernetes cluster. If you are not using Knative, you should be using it. But Kratix is going to do a bunch of other things, like for example, have that configuration in mind, and just keep sync with this by using the GitOps toolkit, right? So if we change what that promise is or how the tools that needs to be installed there, Kratix will keep kind of like a single source of truth that it's going to keep in sync with that specific environment. And that enables you kind of like to do monitoring on the cluster, keeping track of for how long that cluster was built, and when do we need to just destroy it if we don't need it anymore. So now I will keep using my developer hat because now I want to request a new instance of this environment. And I will just do that, as you can imagine, by just creating a resource of that promise. And we can take a look at that. If you take a look at my Kubernetes clusters here, again, you can see that the previous one that I've created, it's gone. Now it's not longer there. And that I have already created like a dev environment right here, right? I will not use that right now. I will just create a new one. And basically, I will just do that by applying a new YAML file, in this case, that I want to show you first. Resource request, the second one, because as I mentioned, I've already created one. And again, not a very good example of properties here. This is just more like configuration stuff. But this is where you're going to configure this kind of like new instance of your environment. It's called DevOps Spicy Dev Environment. And I will apply this resource. Resource request 2. I need to make sure that I apply the right one. And again, as soon as I create this, Kratix is going to monitor this new resource that was created. I will have now a new type of resource that I can list. Not get pods, but I can just list this new spicy dev environments kind of type. Again, if you are building user interfaces, so users like development teams don't go against your platform cluster directly using kubectl. They should go through it and create requests just using a user interface, or another more like abstracted tool from Kubernetes itself. I do believe that Kubernetes is too low level for development teams just to understand how all this works. But at the end of the day, no matter what UI you have or what kind of like tool you expose to them, they will be just creating these resources in one way or another. And as you can see now, I have two environments, one that's called DevOps Spicy Dev Environment, and then the other one that I've created before that it's already running. And if you take a look at the pods here that I have, I should have kind of like a pipeline. I think that maybe this one that I just want to show. That it's not going to show anything important, but basically this is just using Crossplane to provision resources, waiting for Crossplane to create all the resources. When the resources are ready, the next step into the supply chain kind of thing is going to install Knative in there. And at the end, I will just get the credentials to access to that cluster, right? So at that point, what I've done is I've encoded the platform, like the infrastructure requirement using Crossplane and this composition, this Crossplane composition. And then I've created a Kratix promise that encodes the actual interface that I want to expose to my product teams so they can go and request new environments on demand. And we're using here like the environment example, but it can be anything you want, right? Like it can be an entire project. It can be an entire application instance that you are installing in these clusters. And now I'm creating a single cluster, but again, you can be creating clusters across multiple clouds. We have seen a couple of presentations this week where companies are actually doing this, right? Like in the financial service, they need to have multiple clouds at the same time. And by provisioning in this way, you just try to keep everything Kubernetes focused if that's your thing. So after waiting for 5 minutes or so, we will get that environment, and our development team will have access to that environment, right? And if I refresh this page, we should be able to see at some point that that cluster is being created. Yes. So we have that cluster, DevOps, spicy dev environment. It's going to take 5 minutes, so we don't have enough time for that now, right?
Go back to the slides for a minute.
So yes. So we will keep our development hat, but Paula is going to do a quick recap, which is here. Yes.
Next one, I think. Yeah.
Next one. There you go.
So that was a lot of YAML.
YAML.
Quite a lot of YAML. But just to recap, what Mauricio with his platform engineer hat on, what he first of all did was using Crossplane, using Kratix. As he mentioned, he's basically configured the kind of the cloud environment ready for the product team, and he's got the tooling ready for that team to be able to start work. So as you can see from here, you've basically got, with your developer hat on, the red hat, he's been able to just go and request spicy dev environment, not worrying about all the stuff underneath, right? The golden path has been paved so that there's reduced cognitive load, as Mauricio said. The developers don't have to worry too much about what's going on underneath with all of that YAML and all of the sizing and the place and all of it. They just request it, and then they get it. The platform engineers, from there, if he was wearing his yellow hat, he would now be sitting there not worrying about tickets coming in or is everything okay? Because they've already configured that path, so the developers are able to request. The platform engineers can just keep an eye out, make sure things are running, but they're not being bombarded with tickets asking for another environment because it's self-service. And as Mauricio said, he hasn't just configured kind of the cloud environment. He's also using Kratix has been able to kind of compose things together. So we've also got Knative ready to use for those developers to start actually focusing on writing code. And also, this is just one example. If the golden path should have a bunch of other stuff, like Mauricio showed at the beginning, if you should have a database or some user access or like whatever the different things are that should be all composed together, Kratix is a way of being able to kind of compose different promises and wire them all together. So it's really, really straightforward. A simple API for the developer just to request a thing and get a thing. So Mauricio's still got his developer hat on.
Yes.
And I know he's very keen to show a bit of Knative.
Yes.
So I'll hand back to you.
Yep. So I think that one thing that to mention in this kind of like previous slide is that, of course, like if you have a platform engineering team defining how these environments are going to be created, you will always have like group of developers that they say, well, but I want Argo CD in that environment as well, right? And that basically doesn't match maybe like the spicy team food requirements. So what Kratix gives you and what Crossplane gives you is like this, abstraction layers that you can use to compose different things and then to reuse that. As this diagram is showing, kind of like we have like the very high level a spicy dev environment promise in this case, but we also have a Knative serving promise in that, right? So we have created another Kratix promise that the only purpose of that promise is just to install Knative into a cluster. Any other team that needs to install Knative can just reuse that promise and then just configure all the other things that they need in there. And you can use Crossplane again just to define that specific infrastructure side of the provisioning. With that, I guess that the next thing is just to think about how do you reduce the cognitive load of developers themselves, and how do you keep allowing them to choose the tools that they need in order to do their work. And for me, it is really important as a developer. I've been using Kubernetes for like 5 years or so. Writing Docker files is definitely not my thing. I keep messing things up whenever I write Docker files. And writing YAML files is not fun when I'm wearing this hat, right? I've learned to write YAMLs because of Kubernetes, but I don't think that everybody needs to be so deep into understanding how Kubernetes works to write those YAMLs. For that reason, an initiative inside the Knative project, Knative is about like serverless and event-driven applications into top of Kubernetes. It's just like an extension that you install in your cluster to make your life easier as a developer. But still, it's Kubernetes. So you still need to write YAML files, and you still need to containerize your applications so they can run in Kubernetes. We have this, something that we presented with Thomas on Wednesday, which is Knative Func, or the Knative Functions, which is basically providing an abstraction on how to build, more like applications using just functions. So this is like more specific, more particular to a specific domain using a very specific programming model. And what I wanted to show you, if you were kind of like in my other presentation, is pretty much the same. But I think that in this presentation, what I want to make sure is that we focus on reducing that cognitive load. Like making sure that our developers, first of all, they can choose their language of choice to build the things that they want to build, and that they don't actually need to worry about how to connect to the database if they need a database to store data when they are building functions. So what I wanted to do is, again, like the same thing that I did the other day, in this case, was to create just a simple function so we can see how that function looks like. And you can do that by just, just creating a directory. It does exist. It did happen the same thing the other day. I'm not deleting stuff for some reason. But let me delete that. Yeah, there you go. And I can create it again. There you go. So I have a directory here, empty directory, nothing in there. And I can use the func CLI to basically create a new template for my project. Something that I didn't mention the other day is that, of course, you can choose different languages here. I'm just choosing Go because it's the fastest to build. And I'm also here choosing a specific template, which is called HTTP. And Func was designed with this idea in mind that you will need to build your own specific templates for your teams. And this is where you curate like the developer experience. You can say, whenever you create a Go project, these are the dependencies that you can use, because these dependencies are certified. The same when you do it with Java, and the same when you do it with any other language, right? So if I create a project there, I can just then use my favorite IDE just to open it. And we can see that the structure of the function is pretty simple. Functions are supposed to be simple code that you can easily maintain and test. And the only thing that I'm going to be doing here in this function is just to write a message. But this is where you will connect to your databases. This is where you are going to send a message to a legacy system or whatever you want to do in this function. What we showed with Thomas the other day was a way much more complex project. We didn't have much time to show the functions that we use for the game that we presented, but I recommend you to go to GitHub and check it out. I will be sharing some links later on. Why are these folks talking about spicy food? I can just not type live. I am hungry, right? It's almost like lunchtime. Why are we doing this to ourselves? So I've just created a function, pretty simple. And the only thing that I want to show here again is that I don't actually need to write a Docker file here. I can just rely that the framework, in this case, the tool that it's called Func, has all the things that it needs in order to build this into a container and then just to deploy it to my Kubernetes cluster. So if I run func deploy, and I give my Docker Hub username in this case, it can be any other private registry if you want to do that. What Func is going to do is going to use buildpacks, the project that I mentioned before. It's a pretty interesting project. Again, it separates the responsibility of defining how your project needs to be containerized. So developers don't need to worry about that specifically. And you can just enable all these nice things like compliance, maintainability, security patching, and all that stuff into more like the platform team. So the platform team can say, OK, If I'm getting like a Go project in this Git repository, I will use this specific build pack that has been certified for my company to transform Go source code into a Go container that can run in Kubernetes. So it's pretty good. Something failed, of course. And this is true, like it's complaining. It says that basically I'm trying to deploy a function into the platform cluster that doesn't have Knative installed. And that's because I forgot to, change to my, look, I have my new DevOps spicy cluster already provisioned. I haven't tried this before. I usually use the other cluster that was created before just before the presentation, and I know that that cluster works. This might not work, so you have been warned. Let's try some live stuff. So this is going to deploy. I think that it's going to trigger the build again. We can wait for a few seconds. It should be fast enough. It usually takes a minute or so just to create the container, push it to the registry, and then just to do that deployment into the new cluster. So what I just did there, like again with my developer hat, I went to Google Cloud and got the credentials, but I would expect the platform team to abstract me from doing this, right? In order to connect to that Google Cloud cluster, I need to have gcloud, like the CLI tool installed, and that's something that you probably want to avoid your developers doing, because again, you will need to maintain that and update that with Google Cloud at all the time. So in this case, again, you are trying to remove that from the development environments. And now it's just deploying the function. It's taking longer than it should because maybe Knative is not running in the cluster, but it says that it is. And I have a public IP, so that basically means that I can interact with that function, right? So yeah, so that's my function. And I think that that's pretty much what I wanted to show. I think that the nice thing here is, again, from wearing the developer hat, I requested an environment, I had the environment, all the things were created, Knative was installed. Again, you can install whatever you want in there. And then as a developer, without writing a Docker file or even YAML, I didn't write any single YAML line. And for me, that's a blessing. That feels like 2022. So I'm happy as a developer. I think that I can take off my hat now because it's Paula time. Yes.
Okay, thanks, Mauricio. That was excellent. Worked really well. Okay, that was a lot. So we've shown you a lot of tooling. We've shown you from wearing the orange hat, platform engineer side, how to kind of put things together using the different tools like Crossplane, using Kratix, how to pave the golden path. And then Mauricio has just shown as a developer how you can then get started, request your environment, get started. You can use Knative functions to write something very simple, and off you go. I want to bring it back to where we started, which is really the why. Why are we showing you all of these things? We've got a lot of choices to make. It doesn't really matter which technology you're using, honestly. There's just still a lot of tools. There's a lot of decisions that have to be made. There's plenty of cognitive load to go around. And we know that we need to try to reduce this. If we want to have any chance of being able to focus on getting our kind of key things done, like getting things into the hands of customers as fast as possible, we've got to try to reduce it. We know that platform teams can do this. Following the team topologies model, platform teams can help. They can pave these golden paths. They can offer the curated experience. They can make it easier for the development teams to actually get on with the jobs of getting code out there. And we know that developers need a good developer experience. As Mauricio said, they don't want to be worried about trying to write Docker files or write YAML. They want to be able to focus on the logic of the code that they want to write, the features that they want to deliver, and they want to be able to get that out. And they want to be able to do it on a self-service basis. They don't want to have to write tickets and then wait for a very long time. Mm-hmm. So I think the key takeaway from our point of view, it doesn't really matter what tech stack you're using. The theory still holds true. If you have an internal platform, or more than one maybe platform team, are they offering golden paths? Are you offering them if you're in that team? What are those golden paths? What do they look like? Are you actually reducing cognitive load for those product teams, or are you increasing it? How can you make those golden paths easier? How can you speed up the flow of value across the business? And just to finish, Mauricio has a book.
And I have some discount codes. I'm basically covering some of these topics there in the book because I believe that from being a developer, I'm writing this book like from that like developer focused because I believe that understanding all these tools in the ecosystem, it's pretty hard. This is still like work in progress. So if you're interested, like I'm really eager to get feedback from it, from the current content that I have, because I'm rewriting most of it right now. But yeah, there is a 35 discount there. And if you are not interested in the book, just keep an eye out, because I'm regularly publishing kind of like different articles around the topics that we have presented today, and Knative as well.
And I don't think we have very much time left for questions. But if you want to, we'll be hanging around up here.
Yes.
So if you want to come chat to us, then please do. Thanks very much.
Thank you very much, folks.